Hello everyone, so welcome to part 2 of the series where I'm just going to show you some examples on parallel lines, transversals, and angles and give you some time to maybe figure out some of these and then I'll show you how to solve them. Alright, so let's get started. Our first question is, angles 3 and 6 form what type of angle pair? So, are they corresponding angles? Are there alternate interior or exterior angles, or are they none of the above? So I want you to pause the video and take some time to solve this. So, how do we go about solving this? First, we need to make sure that the angles we're dealing is a set of parallel lines. So we can see that between these two parallel lines, we can actually see equal distance. And even if you extend this, you can surely see that they won't meet. So yes, we are dealing with a transverse line that's crossing through a set of parallel lines. So we can go ahead further with this question. So we see next is 3 and 6. Angles 3 and 6 are in fact between the two parallel lines. So these are a set of interior angles. And so we can actually get rid of B because we're not focusing on exterior angles. In fact, if you look at the position of 3 and 6, they aren't even on the same side of the transverse line. So because they're not on the same side, or to be more precise, the same position, we can also get rid of A because they're not corresponding angles. In fact, the angles 3 and 6 are on opposite sides of the transverse line. So this makes them alternate interior angles because they're alternating on opposite sides of the transverse line, and they are interior because they are between the two parallel lines. So in fact, our answer is C. What we also need to recognize is our Z shape. So the Z shape would help us figure out the alternate interior angles. But in this case, 3 and 6 are not only our alternate interior angles. If we were to draw the Z shape on the opposite side, so from here to here to here, in fact 4 and 5 would be our alternate interior angles. Next question. So angles X and Y form what type of angle pair? So go ahead, solve this. Are they corresponding alternate exterior, alternate interior, or none of the above? And I'll explain to you shortly how to solve this. So go ahead. Alright, so this is how you solve this question. This question may seem a bit hard, especially since we're dealing with one extra parallel line and one extra transverse line. So before we even get started on how to solve this, it's always a key thing that you should remember to always select a set of parallel lines and one transverse line that you're working with. So in this case, Y and X are lying on this transverse line. So that's the one we're going to focus on. And Y and X also lie on these parallel lines. So those are the other set that we're focusing on. So if we look at Y and X, these two angles are not interior. So we can get rid of C. In fact, Y and X are on the outsides of the parallel lines. So they are exterior angles. And if you look at the position of Y and X, they are on opposite sides of the transverse line, so they are alternate exterior angles. And so our answer is B. And why is A not correct? It's because Y and X are not in the same position on the parallel line. So if X was in fact over here, then they would be on the same side or the same position on each of the parallel lines, so they would be corresponding. And that's only if X is over here. Alright? Next question. Angles X and Y form what type of angle pair? So again, I want you to go ahead and solve this question. and try to use the same approach as the previous question. So go ahead, take some time. Alright, so this is how you solve this question. Again, we need to focus on finding which set of parallel lines and transverse lines that we're going to focus on. So x and y are lying on this transverse line, so that's our most important one. And in terms of parallel lines, it's this one here because that's where x is lying, and this one here because that's where y is situated. The next step would be to find the relation of the angles. So if you look at x and y, you can see that they both aren't interior and they both aren't exterior either. So we can get rid of C and B. If you look at their position, they are in fact on the same side of the transverse line on each of the parallel lines. So x and y are in the same position, which means that they are in fact corresponding angles. So the answer for this question is A. Alright, so the next question. Angles 3 and 6 have equal angle measures, also known as congruent angles. So is that true or is that false? And explain your answer. So go ahead, pause the video and take some time to solve this question, and then I'll explain to you shortly. So this is how you solve this one. For this one, we need to make sure before we even solve it that we're dealing with a set of parallel lines. And so let's go ahead and see if these two will actually meet. If you actually trace along this line, eventually you can see that they both will meet somewhere along here. So we can confirm that these two are not parallel lines. And so 3 and 6 are not congruent angles, and so the answer is false. And the reason for that is because these two are not parallel lines, so whatever rules that I explained in the previous video would not apply. Okay, so the next question. Can you solve for all the angles in this diagram? So they gave us 107 degrees and 29 degrees. So using that, could you solve for the rest of the angles? So this seems quite tough, but if you do a little bit of thinking, it's actually quite easy. So go ahead, take your time, and I'll tell you shortly how to solve this. Okay, so how do we solve this question? So they gave us two angles, but instead of focusing on this side, which has a bunch of angles really close by, seems kind of messy, I'd like to focus with this side first, because it's just an intersection between two simple lines. What we also notice is that when two simple lines cross or intersect, it actually forms a pair of vertical angles. So over here, angle 17 and 29 degrees are actually a vertical angle pair. So that means angle 17 is equal to 29 degrees. But that's not the only vertical angle pair existing. 18 and 16 are also vertical angle pairs. So if you look at it, we know that adding 29 degrees and 29 degrees, which equals to 58 degrees, you can use that to find how much angles are remaining to be distributed among these two. So one important thing that you must keep in mind is that when two lines intersect, it equals to 360 degrees. So using that, we know that 360 subtracted by 58 is equal to 302. So this 302 right now tells that when these two angles are added together, it equals to 302 degrees. So to find how much each angle is worth, all we need to do is just divide it by 2. So 302 divided by 2 is equal to 151 degrees. And the reason why we divided by 2 is because this is a vertical angle pair, so they are exactly the same angle measure, so they're congruent angles. So we can divide it by 2 to find how much each one is. So let's just go ahead and replace each one of those angles with 151 degrees. Okay, so the next step would be to find the relationships with the angle 107 degrees. Remember, we always want to focus on one transverse line at a time with its set of parallel lines. So we're focusing on transversal A. So let's focus on 107 degrees. Again, just like we saw in the previous kind of angles over here, we can see that 107 degrees make a vertical angle pair with angle number 5. So they both will have the same exact measure because they're congruent angles. So we can replace angle 5 with 107 degrees. In addition, 6 and 7 also form a vertical angle pair. And just like we did before, we would need to find what each one is worth. So to figure that out, first add the 2 degrees that we know, 107 degrees and 170 degrees, so that equals to 214. We want to know how much both of these are equal to. So when we also know that the whole thing is equal to 360, right? So 360 subtracted by 214 is equal to 146. So that's what these two together are worth. So both angles 6 and 7, if you add them up, equal to 146 degrees. Now divide that by 2 to get each, and we get 73 degrees. So 73 degrees is the answer for both 6 and 7. So let's go and replace that. So the next step would be just simply solving for the rest of the angles on the transverse line. So if you look between the relationship of this to this, we can see that both angle 1 and angle 107 degrees are in the same position, but just on different parallel lines. So these are called corresponding angles. So if you know the relationship between both of these angles, they have to have the same angle degrees because they're congruent angles. So we can just go ahead and replace each one of these angles to the degree that matches their position. So angle 1 and angle 100 and this angle over here are in the same position. So 107 degrees can be replaced with angle 1. And next one would be angle 3. So again, we saw that 3 and this angle over here are in the same position. So we can replace that with 107 degrees. Next, we know that both of these are equal to both of these. So the next step would be just simply replacing angle 4 because it's in the same position as this angle over here, and the remaining angle, angle 2, is in the same position as this angle over here. Okay, so we want to solve all of these angles, but where do we want to start? So if we look over here, we don't want to start over here because this transverse line has no relationship with this transverse line. Remember, we're always focusing on one transverse line at a time. And so, if we look over here, we really have nothing to solve. So let's start over here. We know that we can actually solve the rest of the angles with this angle because it in fact is a part of a triangle. And we know that a triangle is always equal to 180 degrees. So let's just go ahead and solve that. 180 degrees subtracted by 29 subtracted by 107 degrees would give us the remaining angle, which is 44 degrees. So angle 9 is 44 degrees. And we also know that angle 11 and angle 44 are vertical angles. So because of this vertical angle pair, we can automatically replace angle 11 with 44 degrees. Angles 10 and 8 are also a vertical angle pair. And using the same steps that we used before, knowing that an intersection between two lines will create 4 angles that equal to 360 degrees, we can solve this. So 44 plus 44 is equal to 88. 360 subtract 88 degrees is equal to 272. And now divide that by 2 to get the angle for each. So that's 136 degrees. Okay, so just like we solved before, these two are parallel angles, and using the angles that are in the same position, we can just quickly replace each one of these. So for angle 15, we can replace this with 136 degrees because they're in the same position. And the reason why we're doing this is because they are corresponding angles, so they're congruent angles with the same angle measure. And then angle 13 is also related to this angle over here, which is why we replace it with 136 degrees. And then the remaining, which is angle 12, is in the same position as this one over here, which is why we replaced it with 44 degrees. And the remaining angle, angle 14, is equal to this angle over here, which is in the same position, so 44 degrees as well. Alright, thanks for watching. Comment for help or suggestions, and comment down below for other topics that you'd like me to make videos on, and don't forget to like and subscribe for more videos. Thank you!